Hello! The objective of this video is to solve and graph linear inequalities using opposite operations. What are inequalities? Well, inequalities are equations that have more than one solution. They're going to have a range of solutions, and they're indicated by these inequality symbols. Greater than, less than, greater than or equal to, less than or equal to. Remember, as you're moving from left to right, if you encounter the bigger end, you're talking about a greater than symbol. If you encounter the smaller end, you're talking about a less than symbol. If you've got a line underneath, that second line indicates an or equal to, which means that you're including the point that's equal, whereas these do not include the point where things are equal. Let's look at graphing first. Here we have x is less than 3. Now, we want to graph it, and some teachers will tell you that you have to have 0 on your number lines. That's not true. You can have a graph without having 0 on the number line. What you do need to have is you need to have that number on the number line. You need to have nice, evenly spaced intervals. And you should show at least 2 values to both sides of that number. So if we're starting off with 3, I put 3 in the middle here. I need to have 2 values to the right and 2 values to the left. I could count up by whatever I want to. I could count up by fractions, decimals. I can do whatever. But I'm going to count up by ones. So we have 4, 5 in this direction, 2 and 1 in this direction. Now we want to include all the values in this graph that make this inequality true. When I plug in the value of 1 for x, I get 1 is less than or equal to 3. Is 1 less than or equal to 3? Yes, it's less than. So we do want to include this point. Do we want to include 2? 2 is less than 3. So yes, we want to include that point. Do we want to include any of the points in between? Yes, all those fraction and decimal values are less than or equal to 3. What about 3 itself? Do we want to include the 3? Yes, because 3 is equal to 3, and we have a less than or equal to, so we do want to include that. So to show that we're including it, we're going to put a filled-in circle there. That's indicating that we're including that 3. And we want to include everything in this direction, so we go that way. Do we want to include the 4? Is 4 less than or equal to 3? No. So that point does not make this inequality true. I don't want to go in that direction. I don't want to include anything in that direction, so I'm going to leave it at that point with the arrow going in that direction. Notice how I put the point just above the number line and the line going just above the number line there. I know when you're trying to draw these, if you actually draw it on the number line itself, it's hard to see them. So I do say you can put them on just above, but make sure it's just above that number line, not up here. Because you put it all the way up here, and I'm having trouble telling whether it's over the 3 or the 4 or the 2. So put it directly above, just a hair's breadth above the number line. Here's x is less than 4. So we're going to graph this one. We put a number 4 in the middle. If I can write a number 4, put a number 4 in the middle. Then we have 5 and 6. In this direction, we have 3 and 2. Less than 4, again, we're going to be going in this direction. We're going to include the 2 and 3. Those are less than 4. 4 itself is not less than 4. 4 is equal to 4. So we know we're going to start somewhere near that 4, but we're not going to include the 4. How do we show that? Well, mathematicians have decided that to do that, we're going to show an open circle. That open circle means we're starting right about here, but we're not including the number 4. We're going to go to the left like that. Funny how the arrows both went in the same direction as the inequality symbols were pointing. That actually does hold true as long as the inequality is solved and your variable is on the left-hand side. If it's on the right-hand side, you actually have to go in the opposite direction. So as long as your variable is on your left-hand side, the inequality will point in the direction your arrow and line need to go in. x is greater than negative 5. So we put a spot here in the middle, negative 5. Now remember, when you're in the negatives, going in that direction, you're actually going to be counting down, negative 4, negative 3. And then in this direction, you get negative 6, negative 7. Because the larger the negative value, the less it's worth. Here we have a greater than 5. It's not including the 5, so again, we're going to have that open circle. Be careful not to dip into the circle, because if it looks like you're trying to fill it in, you may get marked wrong for having a filled-in circle. So try and keep it to one line, one circle line like that. And greater than means we are going to go in that direction. Negative 4 is greater than negative 5. Negative 3 is greater than negative 5. And if I keep going this direction, I am going to hit the positive numbers, and every positive number is greater than any negative number. So we are going to go in that direction. Here we have negative 40. X is greater than or equal to negative 40. This time, I feel like counting by tens. Is that a problem? No. Is it really going to help us with this particular graph? No, but it might help us in future graphing. So just know you don't have to count by ones. You can count by other numbers. Greater than or equal to negative 40 means we are going to include 40, which means we have a closed circle, a filled-in circle above the negative 40. Greater than means we're going to include everything to the right. There is our graph for x is greater than or equal to negative 40. Moving on. Solving using opposite operations. You may remember when we solved equations, if you have x plus 3 is equal to 8, we did the opposite operation to get the variable alone. Again, you want to get the variable all alone and everything else to the other side of that equal sign. So to get that 3 over the other side, instead of adding 3, I'm going to subtract 3, which gives me x is equal to 5. And there's my answer on this one. Here, I would add 7 instead of subtracting 7. That gives me x is equal to 11. You're going to do the same exact thing with inequalities. Instead of adding 4, I'm going to subtract 4 from both sides. And I'm going to get x is less than or equal to 2. Instead of subtracting 8, I'm going to add 8. And when I do that, I'm going to get x is greater than 13. There is a little twist, though, with inequalities. There's a reason why we have to cover this separately from just plain solving equations. Let's take a look at what happens when we look at the graph and then solve it and look at the graph again. Here, we have negative 2x is less than 4. If I plug in some values, make my little table here. I plug in negative 2 into negative 2x. I'm going to get negative 2 times negative 2, which is 4. Is 4 less than 4? No, it's equal to it. So at negative 2, I am going to have my open circle value. It's right when these two are equal. If I plug in negative 1, negative 2 times negative 1 is going to give me positive 2. Is positive 2 less than 4? Yes. So it looks like I'm going to go in that direction. What about negative 3? If I plug in negative 3, negative 2 times negative 3 gives me a positive 6. Is positive 6 less than 4? No. So I don't want to go in this direction. I want to go in that direction. But Mr. Funk, you said that when the x is on the left-hand side, the arrow points in the direction. It's not pointing in that direction. Something's funny here. Let's see what happens when we solve it. If I have negative 2x is less than 4, and I divide by negative 2. These will cancel. I'll get x is less than negative 2. But again, let's go in that direction. If x is less than 2, then negative 3 would work. But when we plugged in negative 3 before, it didn't work. something odd's happening here. Let's try the next one here. Let's look again at the table. So I'll plug my x values and I'll see what I get. When I plug in negative 9, I get negative 9 over negative 3. Negative over negative is a positive. 9 divided by 3 gives me a positive 3. Is 3 greater than 2? Yes. So at negative 9, that point's going to be included. Let's plug in negative 6. Negative divided by negative, again, is going to be a positive. 6 divided by 3 is 2. So at 6, we're going to get the equal point. That's good. Knowing that we're not there, the equal point means that this is going to change something here. When I plug in negative 3, I get negative 3 over negative 3. Negative over negative is a positive. 3 over 3 is 1. Is 1 greater than or equal to 2? No. So I don't want to include this spot. I want to include this spot and everything in this direction. Yeah, that's funny. Again, it's going in the opposite direction of that. What happens when we solve it? When we solve it, if we solve it using the normal method, we get negative 3 greater than or equal to 2. We would multiply by negative 3, and we end up getting x is less than or equal to negative, x is greater than or equal to negative 6. But negative 9 is not greater than or equal to negative 6. And we show that that works. These two can't be the same. Something's wrong here. Well, as it turns out, the problem is that any time you multiply or divide in the process of solving, multiply or divide by a negative, your inequality is going to have to flip around. So here, after solving this, it's still the same process. I still divide by negative 2, but when I divide it by the negative, instead of being a less than now, it's going to be a greater than, which matches the graph. When I multiply by negative 3 here, instead of being a greater than, it's now going to be a less than or equal to. I have to flip it around. Anytime you multiply or divide by a negative in the process of solving an inequality, you have to flip the inequality symbol around. Change it from greater than to less than, or less than to greater than, depending on what you have there. Anytime you're multiplying or dividing by a negative. So let's take a look. Take a moment. Solve these. You don't have to graph them, just solve them. Pause the video, solve them out, using the rule that anytime you multiply or divide by a negative, you have to flip the inequality, and we'll go back over in a minute. Pause the video. All right, welcome back. To solve this one, I would divide by negative 4. I am dividing by a negative in the process here, so my inequality has to go from a less than to a greater than or equal to. And I end up getting x is greater than or equal to negative 4. Here, I'm going to multiply by negative 4 to solve. And again, this is a multiplying by a negative in the process of solving. So the 4's will cancel here. I'll get x is less than or equal to. I've got to flip the inequality because I'm multiplying by a negative number here. Less than or equal to negative 32. Over here, I'm going to multiply by 2. Now, some of you may go, well, hey, look, there's a negative there. You're multiplying by... I'm multiplying by a positive number in the process of solving. It's what I'm multiplying by, not what I'm multiplying over here, but what I'm multiplying by. I'm multiplying by the 2. The 2 is positive, so I do not need to flip this. This stays a less than. I get x is less than negative 20. You only have to flip it if you're multiplying by the negative in the process of solving. Now, some of you may say, well, there's a negative here. I don't have to worry about that, but there is a negative over here. In the process of solving this, you are dividing by a negative. The fact that it becomes positive over here means nothing. These still cancel. You still have to flip the inequality. Instead of being greater than, it is less than. But it's going to be a positive 3. It doesn't matter that this ends up being positive. The fact that you divided by a negative number forces that flipping of the inequality symbol. Let's look at two-step inequalities. To solve these, we start off by doing the opposite operations in the opposite order of operations. I subtract 3 first. That gives me 2x is less than or equal to 2. Just because there's a negative here doesn't mean I'm flip-flopping. I'm subtracting. Or you can say I'm adding a negative 3, but I am not multiplying or dividing. So I don't have to worry about the negative part there. It stays the same. Here I divide by 2. I'm dividing by a positive 2, so the inequality symbol stays the same. I get x is less than or equal to 1. 1, 2, 3, 0, negative 1, or equal to, filled in circle, less than or equal to, going this direction. There's my graph. There's my solution. 2 parts to that. Next one. I'm going to add 5 to both sides as a first step. That's going to give me 3x is greater than 9. Divide by 3, and I get x is greater than 3. So I put a 3 here, 4, 5, 2, 1. It is open. It's greater than, but it's not greater than or equal to. So we have an open circle, and it's going to go in this direction to the right. Here's some negatives in there. Here we'd start off by instead of adding 1, I would subtract 1. And that would give me negative 2x is less than 2. Then I would divide by negative 2. And when I divide by the negative, I have to flip the inequality. So it's no longer less than, it's now going to be a greater than. And I get x is greater than negative 1. So we have negative 1, 0, 1, negative 2, negative 3. Open circle, going in this direction because it's a greater than symbol, going to the right. There we go. There's my graph. Here, start off by adding 8 to both sides. That gives me x over negative 5 is equal to 10. Then I have to multiply both sides by negative 5. Multiplying by a negative means I am going to have to flip the inequality. So it's no longer a greater than, it's now a less than or equal to. And 10 times negative 5 is negative 50. So we have negative 50, negative 49, negative 48, negative 51, negative 52. Did I have to count by tens? No, I counted by ones this time. As long as I show a couple numbers to both sides, I'm good to go. Closed circle because of the or equal to the left because we have a less than symbol with the variable on the left-hand side. Here, we start off by getting rid of the 6, so we have to subtract 6. That gives us negative x over 4 is less than negative 9. Then I have to multiply by negative 4. Multiplying by the negative means I need to flip this, so it's now going to be a greater than symbol. So I get x is greater than a positive 36. 36, 37, 38, 35, 34. Open circle. To the right, because it's heading to the right there, greater than. There is your answer for that one. Now you do. You're asked to solve and graph the following 4 equations. I've given some nice graph values here to work with over there. This one I did not because I want you to figure it out. You may have to use something different than 1, 2, 3, 4. Pause the video, give them a try, and we'll go over it in a moment. Welcome back. Start off by subtracting 1 from both sides here. You get negative x is less than 4. You still have negative x, so you have to divide by negative 1 to get rid of the negative, which again is going to flip that inequality. So now you end up with x is greater than negative 4. So greater than means open circle over the negative 4, and we're going to be going off to the right, like that. Here we add 2 to both sides. We get x is greater than 8. No change to the inequality. Greater than means an open circle and going to the right. Subtract 5 first here. You get 2x is less than 6. Divide by 2. That's dividing by a positive, so I don't have to change it. I get x is less than 3. Here's 3. Open circle because of the less than, to the left because it is less than, left. There we go. Here we have what could be considered a one-step. It could be a two-step equation. I like to take it in 2 steps. First, I'm going to get rid of the 3 by multiplying by 3. That gets rid of the 3, gives me negative 2x is less than or equal to 12. Then I divide by the negative 2, and when you divide by a negative, you've got to flip it, so it becomes x is greater than or equal to 12 divided by negative 2 gives me negative 6. Spot in the middle for negative 6, negative 5, negative 4. Not very even with the spacing there. Remember I said the interval should be fairly even. And negative 7 and negative 8. Greater than or equal to negative 6. Filled in circle because of the or equal to. Greater than means we're going to the right. There are your solutions. I'll see you in class. We'll do some additional examples.